The question is, have we removed all the ambiguities here? Remember, there were two kinds of ambiguities, one because of operator precedences and the second one is because of the associativity of the operator. Left association, have we implemented that? And here is how we do it. Remember, in the original grammar, we were allowing the derivation of the expressions, recursive derivations, to occur on both of the sides here. This could further expand into add op, or this could further expand into an add op, and that would create a problem. But now we have forced the grammar to become only left recursive by implementing the further derivations of expression through this expression and not on this side. So in short, this has been replaced by term, and so this can only derive a star further. This cannot derive a plus, which was the case earlier. So that's how we have removed the ambiguity here, by getting rid of expression from here and just having it over here. And then in a similar way, we do not allow the recursion of term on both sides. We restrict it to occur only on the left hand side. So which means that whatever further terms we are deriving are going on this side, and their results will get accumulated and finally be used over here. And so that's how we are implementing the left associativity. So no recursion of term on this side. This can only go to factor and derive the parenthesis or ID, whatever. And now we are going to demonstrate that the modified grammar, which only allows the recursion on the left hand side, implements the left associativity. So again, the ambiguity here would be this, that if we are able to derive this particular expression, then the result would be do 2 minus 3 first and then subtract that from 1, which would be a wrong thing. If we are not able to derive this 2 minus 3 but are only allowed to do 1 minus 2 and then use that result to be combined with minus 3, then it is implementing the left associativity, and that the result will be 1 minus 2 minus 3, which will be minus 1 minus 3, which will be minus 4. So let us see how the grammar prevents this being grouped together, 2 minus 3 being grouped together. That's the question that we are going to answer through this example. Again, let's start with the derivation here, which derives the plus or minus operator. So for that matter, we have to expand the expressions into expression, add op, expression. And so first we are going to demonstrate how the ambiguity is present in the original grammar, and then we are going to show you how the modified grammar removes the ambiguity. So let's start here. So what is going to happen here is, first we are going to apply this rule of expression, add op, expression, and we are going to choose to expand the left hand side first. And so what happens in this particular case is, we're going to expand this to expression, add op, expression, and that is going to derive this 1, that is going to derive the negative sign. Then finally, the right hand side expression is going to derive the 2. This is going to derive the second negative sign, and then finally we are going to derive the 3 here. So this is one kind of a parse tree. What kind of association has occurred here? We are going to evaluate 1 minus 2 first. So a left association has occurred. Then the result is going to be used, and then 3 is going to get subtracted from it. And so the net result is going to be minus 4. 1 minus 2 is going to generate minus 1, and then 3 is going to get subtracted. That's the result here. So as shown here, this is the correct parse tree for implementing the left associativity of minus operator here. Now, is that the case that this original grammar, which allows derivations of expression on this side as well as that side, implements only left associativity, or does it also allow implementing something else? Let's see. So first we started again the derivation of expression minus expression. But in this particular case, instead of expanding on the left hand side, we just expanded it to term, let it go to factor, and matched 1 using it. And this particular expression, which was on the right hand side, now we are trying to expand to implement 2 minus 3 here. And so let's see if we are successful in that. So in this particular case, expression goes to term, goes to factor, goes to 2, that goes to minus, and finally that goes from expression to term to factor to 3. And that's how we are able to completely match this 1 minus 2 minus 3, even using this other parse tree over here. Now as you can see here, both are legal. But in the second parse tree, we have chosen to expand on the right hand side and derived a minus operator out of it. And so the association here is, first we are doing 2 minus 3, generating this result, and then trying to use this for subtracting from 1, and that's the problem which we are going to face here. And the result here is plus 2, because if we do 2 minus 3, we'll get minus 1, and 1 minus minus 1 is giving us plus 2. So obviously this is a wrong parse tree. We should not be allowed to derive this. If we were to use left associativity of minus operator, then the result should be only minus 4, and for that matter, we should be able to generate only this parse tree. And so what is the catch here? What is the problem here? The problem here is this expression. This expression is what we are used and are able to derive this negative operator here or minus operator here, and we should suppress this particular part by not allowing this to be expression, but by allowing this only to be term. So the conclusion here is ambiguity is present still, because of left associativity of minus is not enforced and the results are different, and so this is a problem.